What we have here is a combination of some plastic materials and some biological materials that can be loaded with heart cells to make these spontaneously beating tiny pieces of heart tissue. We feel that these can be used to repair congenital heart defects in infants and children with tissue that acts like the rest of the heart and will continue to grow as the heart grows and the child grows. The current technologies of repairing congenital heart defects in these, as we call them, full thickness defects, where there's a hole in the contracting heart tissue, work very well in the short term, but in the long term, they greatly increase the risk of arrhythmias, of heart failure, and of sudden cardiac death. We feel that by putting in a biological tissue, we can have greater long-term outcomes. Also, the tissue we're putting in is beating immediately on implantation and is conducting the electrical signals that go across the heart. We feel that this should give better outcomes and better heart function immediately, and that using materials like this can allow surgeons to expand the types of therapies that they can do, replacing areas of the heart that are very critical to heart function, where it's absolutely necessary that they beat very quickly after surgery. In my vision of the laboratory, I think this brings us closer to a very long-term goal of being able to construct an entire biological heart out of human cells and some artificial scaffolds and materials, where we could, in the laboratory, grow a heart that then could be used as a transplant in a patient. If it's a child, that heart would continue to grow with the patient and could really get around the issue of the lack of availability of heart for heart transplants in the United States.